Stuff out? We didn't have an assignment. We didn't finish a lesson. So, no, we're just going to hop right in. I'm a little iffy on how long 6566 are going to take us. So what we're probably going to do today is finish 6.5, go into 6.6. On Tuesday, calendar up there, updated, last 3 weeks, here we go. What we'll probably do on Tuesday is finish 6.6, give you time to work, call it good. And then because we are a wee bit struggling with our word problems, I think what we'll do is instead of trying to introduce anything new or here's this random concept, on Thursday next week, we'll just get in extra practice with the words, a little bit of this graph stuff from the next 2 days. And I'll probably throw a couple of systems at you from section 6.1 through 3 that are not as nice. Like, can we still do the system when we got fractions and decimals and all that business? Okay, so instead of introducing anything new, we'll just start there. We had a early release on Wednesday. That was kind of one of the debates that we were talking about in the math department was where we specifically want you all to start next year. Because all of our half and one are going over to the new curriculum. And, well, let's just say that we're not where we're supposed to be. So we have to figure out how to square those two ideas. But what we're probably going to do next year is have y'all start Algebra 1 with systems. So that's your review of everything linear and equations. So it won't be much. It'll be like 3 days. Be like 1 day of can you do equations, 1 day of can you do lines, 1 day of can you do systems and graphs. Like, so it'll be kind of a 3-day review and then kick you into the deep end. But that's our plan. Finish chapter 6 next week. Your quiz will be on the 16th, that Monday. We'll have 3 days of in-class review, 1 per chapter, and then it is final time. That is the final calendar up there and ready to rock. If any of you know that you're going to be gone those last 3 days, 25th, 26th, 27th, any of you in track? Are you good? No. Okay. If you qualify for state track is, I believe, on the 27th, if not the 26th. If you qualify for state track, you will miss finals. You are going to have to make them up either beforehand while we're doing our review or after the fact. You got to come back after Memorial Day weekend, and during those 2 or 3 days where teachers got a bunch of meetings and stuff, we'll set you up with like the guidance office or in the library or something like that, and you have to take your final proctored with someone else. So if you're going to be gone those days and you are unable to make up your finals during those days, you got to come back after the weekend. That kind of sucks. But sometimes you do what you got to do. Now that the final 3 weeks are live, we got everything kind of locked in, assuming we don't have a snow day. The last 3 years straight, we have had a snow day within 10 days of finals. I want you to think back to the last few years. Last year, we had, what was it, Spearfish got 21 inches. Outside of Bell, we got 18. 7 days before finals. Like, I remember the mountains that I was moving around my neighborhood. And it was something. So as long as we don't have any kind of freak storm show up in the next few weeks, that's our schedule. We're locked in. We're good to go. That means you can change your final if you want. I know a couple of you have expressed interest in that already. Maybe your white 3 is academic life skills. Maybe it's PE and they're just having you do the final earlier because PE teachers do stuff like that. If you want to take your White 4 final, which is currently scheduled for Block 2 on that Friday, at a different time earlier on Wednesday or Thursday, you talk to me. You schedule it the week before. You tell me by a minimum of Friday the 20th, hey, I want to do my final during the morning block on Thursday. I'll sign you up and you're good to go. Okay? Your final will be not open all notes. It will be the review and whatever you can jam on there. So those 3 days of review that we do are basically going to be an extended version of our normal review and quiz. And then I'm just going to cherry pick questions from those 3 things, those 3 days, and those will be what your final is. You put whatever notes you want on there, that's what you get for your final. And the reason I'm not doing open everything is because you turn that in with your final so that kids can rearrange their finals if they want. Okay? Aiden was just asking, double checked the handbook. It is after 5 days of absence. Some of you are already well past that. 5 days of absence in any of your classes this semester that weren't for COVID quarantine or school activity, or in certain circumstances, medical health emergency, stuff like that, doctor notes, all that. Like I had to be out of school for 3 weeks because I got mono kind of stuff. Aside from that, you're allowed 5 absences max per class. Other than that, you have to pass the final to pass the class. A couple of you are in that boat from last semester, where if you don't show me that 70, if you don't pass your final and your class second semester, you're see you again next year. Well, someone else will see you again next year. I take that back. Greenwalt will see you again next year because he's taking over Scogan's spot, so he'll have all the algebra halves. So, make sure you pass final. Oh, hell no. I took this one this year because I needed to balance out my inclusion algebra because that's an every other day class. God, no, I haven't done an algebra 1 or algebra half for probably 7, 8 years. I'm a big fan of having my SPED class and my upper level math. Ping pong both. Let's go. We did both these. I'm pretty sure. Frank, you rat son of... Okay. There we go. Did we get to the here? I think we were talking about the thing and then we just didn't have enough time. Right? Early release. So, here's how it goes. Nice and simple. I'm going to graph a line the same way that I've been graphing a line for the last 2 months, 3 months. I'm still starting with a y-intercept of -2. I'm still using my slope. If you need to use those arrows, it's positive, so I go up and to the right. Up 1 over 1, 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 or you can flip it. Down 1, back 1, down 1, back 1, down 1, back 1. Well, what's the catch? What was the catch? What was going to be different about these now that I have Pac-Man up there instead of equal sign? The 0, 0 trick? I'm going to have to shade one way or the other before I get to the shading. What kind of line do I use? Do we remember that? Okay. If you have either greater than or less than, dotted line. If you have greater than or equal to, less than or equal to, it's a solid line. Pretty simple. This is a chain of open circles. So just like first semester, less ink here, less ink there. This is a chain of filled in circles. So it's a solid line. More ink here, more ink there. This one, less ink here means less ink there. You got to turn this into a dotted line. Now, nearly every math student since the dawn of time who has done these has at some point just accidentally, you bust out your straight edge, you do that, and then you're like, ah, crap. Don't erase the whole line. Just go back and erase little bits of it. Okay, dotted, dashed, whatever. You can still see that it's not a solid line, right? Okay, now I'm going to do that 0, 0 trick. See, I don't know which way I'm going to go until I find out whether something makes the inequality true or not. If I have y is greater than x minus 2, I should be able to put something in here for y and x and determine whether it's true or not. The easiest one in the world, 0, 0. Zeros are easy to work with. Put a 0 in here and a 0 in there. And I get 0 is greater than negative 2. Is it better to be flat broke than owe your friend $2? Yeah, it is. So if this is a solution for the inequality, that means everything over here is a solution. I'm going to shade that side. And because you don't want to just see me up here coloring for the next 5 minutes, I'm going to do that. Okay? I really wish I could make the marker on here bigger, but that's it. Make your line the same way you've been making lines. You just have to check whether it is solid or dotted and which way do you shade. If I had done that inequality and it didn't work, well, if it's not a solution, nothing on that side is a solution. Shade the other way. So, get your y-intercept. Make your slope. Look at the inequality, solid or dotted. Plug in 0, 0. Does it work or does it not? I like those of you that I'm seeing still use those arrows on your slope. It's something small, but boy, does that make a difference sometimes. How many times have we been solving equations and putting that little line down the middle through our inequality or equal sign as our saving grace? It's always funny when you use the phrase saving grace and you actually have someone named Grace in class, right? It's also a really good TV series from early 2000s. You're kind of into the whole grunge retro thing. I bet you'd like it. Extremely irreverent police officer who effectively is going to go to hell and is assigned a guardian angel to correct her life choices. But she just doesn't care. Lots of cursing and bad things in that show. It's great. So, I normally want to use 0, 0 because it's just the easiest point. But if my line goes through 0, 0, I don't want to choose something on the line. I'll pick something right next to it. So as long as my line doesn't go through the origin, I'm going to use 0, 0. Okay, watch your signs. Well, is that a true statement? So if that is a true statement, that means that this point is a solution. If this works, everything on this side works. Yep. Okay, should be fairly quick. Positive 1, y-intercept. Slope is 1/2. I always go to the right. Positive or negative tells me up or down. Positive, so I go up. Up 1, right 2, up 1, right 2. Or I can flip the script and go down 1, left 2, down 1, left 2. I look at the inequality, look at Pac-Man. More ink here means more ink there. So, solid line. I'm asking, does this point work? Because it doesn't go through the origin, I'm going to try the origin. And we really like that because if I jam zeros in, I mean, it's pretty easy to work with zeros. I get 0 is less than or equal to 1. Is that true? So if that's true, that means this is true. It's kind of like, I want to know if I should use more force or less force than a ball-peen hammer to bust up my ice. I use the ball-peen hammer and it just goes tink. Well, that didn't work. That means nothing smaller than this is going to work. I need something bigger. Wham. But if I did, smash. That means everything bigger than it is also going to work. It's this idea of just logic. If that works, then everything on this side works. And you can test that. We use 0, 0. If you said that that side works, you should be able to put anything from that side in. I should be able to take the point 4, negative 4 and put it in, and it's going to work. Well, negative 4 less than or equal to 1/2 by 4 plus 1. What's half of 4? 2 plus 1 is 3. Is 3 greater than or equal to negative 4? Yeah. So if one point on that side works, they will all work. If one point on that side doesn't work, then none of them work. I want you to look at these two and say, do you have a easier way to do that? The whole plug in a point and check thing, it works. It's great. But there is another way. I want you to look at those two graphs side by side. Just shaded better than that. Look at the equations. Or sorry, inequalities. Look at your inequalities and look at where you shaded. Can you come up with a cheater plan?
Like low pack things? If it goes through greater than like that side, then it's on the top, and then if it's the this way, it's on the bottom.
Okay. Now, I don't know if the rest of the room heard Mighty Mouse up here, but dead on. If you have this in slope-intercept form, if I say y is what then the line, it just flat out tells you where to shade. This says y is greater than the line. Where are y's bigger, up or down? Shade up. This says y is less than or equal to the line. Where are y's less? Where are they smaller? That way. Okay, it's just right there. But the catch is it only works when you got y by itself. Only works if you got it in slope-intercept form. If you don't, this doesn't work. Okay, but it is a handy little cheater. In fact, that's how we usually use it in other classes. These. Do you remember what x equals number and y equals number look like? Well, all lines are straight. Okay. Either no slope or zero slope. Either vertical or horizontal. And we wrote those out ages ago. We said if I have x equals number, it's a vertical line. If I have y equals number, it's a horizontal line. So when I say x is greater than -1, well, I just make a horizontal line at -1. And like a jerk, I wait for everyone to finish making that line, and then I ask you, is it supposed to be solid or dotted? Less ink here, less ink there. So I'm going to come back and do this. Who did their math in pen? Hi. That's a Y. You know what? I'm just going to give myself that point because the look on your face is, why are you doing this? You just said the thing and then you didn't do the thing. Okay. X is -1. Vertical line, and it is going to be dotted. Less ink here, less ink there. I was just so hell-bent on -1. And then that same idea of if x is greater than the -1, is that left or right? What numbers are bigger than -1? Those ones. If I say y is greater than or equal to -2 or +2, that's a horizontal line. More ink here, more ink there, that is a solid line, and I say y is greater than the 2. 0 isn't greater than 2. 5 is greater than 2. So I shade that way. How many of you just got that like murder shape on your paper? Okay. You can tell who the artists are when we do these because their shading is like it's all even all the way across. It's nice and level. It's got that good gradient to it. You can tell who's not the artist because it just looks like they murdered a pencil on their paper. So, vertical or horizontal? Make your line solid or dotted. Which way are you shading? Well, got a little bit of a dilemma already with round 1. When your graph only goes to 5, how do you graph things that are past 5? Change the scale on it. Okay. Make this go by 2s. And say now that's at 2, 4, there's 5. Less ink here, turn it into a dotted line. Y's are less than everywhere to the left. Go again. Y is less than or equal to -2. Why do I keep seeing negatives? Positive 2. Everywhere less than that. So pick numbers that are smaller than it and shade them. Okay? So they're really simple, but we do have to know how to do them. Honestly, those are the ones that seem to kind of get kids more often than anything because they expect it to be more complicated than that. All right. So far, this is just the mechanics of it. Can you do it when they ain't pretty? These are not in our slope-intercept form. Can you still do them? We got the time. Either you remember how to graph by intercepts, or you have to rearrange each of them so y is by itself. Whatever your jam was, I no longer care. I just care that you get the correct line on there. So do you remember how to graph by intercepts? Cool. Do it. Do you not remember that or don't even know what I'm talking about? All right, get that y by itself. Because that is your fallback option. Got kids who will come back for Algebra 2. The last thing they need as a bare minimum to get into a 4-year university. It's been 2 years since they did lines in Algebra Half. And I say, all right, graph the thing. And they got no clue. But they'll fall back on y equals mx plus b. Because that was the thing that worked for them. Use what works for you. Just make sure that these get graphed. Watch your signs. Okay, they shouldn't be a long, drawn-out process. We spent a whole semester working on integer operations, solving equations, solving inequalities, all that kind of stuff. Probably one of the more dreaded lessons of first semester was 2.5, literal equations. Well, I said you have to know how to rearrange something even if you don't get x equals number at the end of it, because you have to be able to rearrange formulas. Well, equations like this are formulas. You got to rearrange them. And if you're doing stuff like subtracting in blue, subtract the 2x and then just forget that negative is with 3y. If you just forget that, it kind of screws everything over. That's why we said we have to know this. We have to practice this. When you divide by, say in blue, -3, are you remembering to divide every single term by -3? That's how math rolls. What you do for one, you do for all. When I divide everything by 6 in the yellow, did you divide everything by 6? Okay, that's what math does. Math is communist. What you do for one, you do for all. Everyone gets the same thing, at least when multiplying and dividing. Are we remembering if you are switching the direction of the, or if you are getting y by itself, are you remembering to swap the direction of the inequality when dividing by a negative? All of this is first semester stuff. You did it. You did lots of it. You probably did okay on it if you're in here. You got to be able to do those things. Now, we also did graphing by intercepts. And I do believe that is so much easier. Put a 0 in for y. X-intercept is 1. Put a 0 in for x. Divide by -1. Y-intercept is -1. Just getting that. Well, I see the ratio between them. Up 1, right 1. So I can use it to make more points. Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And you see it's that exact same line as if I had just started at -1 and used the slope. I don't have to rearrange stuff if I know how to graph by intercepts. That's a solid line. Is this correct? Mm-mm. More ink here, more ink there. And then if I plug that 0, 0 in there, notice all of these are in standard form, so I can't do the above or below the line trick. But if they're in standard form, aren't every single one of these going to be 0 is blank then number? That's still pretty easy. Is 0 greater than or equal to 1? Nah. So I shade this way. Because if 0 is not a solution, nothing on that side is a solution. You plug in 0 for y. 2x equals 6, x-intercept is 3. Plug in a 0 for x. -3y equals 6, divide, y-intercept is -2. You see enough between those 2 points to make the slope. Up to right 3, which is the slope if I had rearranged it. I can also go down to left 3. More ink here, more ink there, solid line. Plug 0, 0 in. 0 is less than 6. If this is a solution, then everything on that side is a solution. I can rearrange it by subtracting 4x, dividing by -3. Starting at -2, slope is up 4, right 3. Or down 4, left 3. Or, if I plug in a 0 for x, get a y-intercept of -2. If I plug in a 0 for y, 6 divided by 4 is 3/2. Well, I can still use that ratio, that slope. From here to here, it went up to right 1.5. I can go up 2 and right 1.5. It's just a ratio. They don't have to be pretty numbers. In fact, we were doing that with, all the way up into pre-calc. I had kids just this morning. The last couple of days, they've been doing asymptotes of hyperbole. And it's just a line. For a lot of those kids, it's been 3-4 years since they've done this in class. Like they learned it. They just forgot stuff. And they were having to do a slope of like 4 squared to 3 over 7. Well, that's awful close to, so that's square root of 48, which is really, really close to 7. Could I go up almost 7 over 7? Go up almost 7 over 7? Yeah. Okay, so sometimes you can ballpark it like that, and that's fine. It's still got the same ratio to it. Less ink here, less ink there. Get rid of that little stare there. And if I plug 0, 0 in, I get 0 is less than 6. That is true. If this is a solution, everything on that side is a solution. And finally, plug in a 0 for y, get an x-intercept of 4. Plug in a 0 for x, get a y-intercept of 2. Down to right 4 is a slope that I can follow. It simplifies to down 1 over 2. More ink here, more ink there, solid line. And do I have a yellow highlighter? No, I don't. So I plug in 0, 0, say 0 is not greater than 12. So we're going to go the other way. I think y'all should know the logical thing. If not there, it has to be over here. You know, can I come home at midnight? No. At 1? No. Well, if going that way didn't work, you better go that way. 11:52. Don't do that. I don't know. Is curfew even still a thing, or do your parents just not care? Set them wild. Let them just go all over town.
Legally, my curfew's 10. Because, like, for driving and stuff.
Yeah. Apparently there's a curfew here.
Really?
Yeah.
Well, if you're, like, younger than 16, I think, or maybe, I don't know.
I know there's a thing where you can't have you can only have one other passenger besides family or something like that. You just did driver's ed. What is it?
Yeah, exactly that. But we found out there's actually a curfew for all of us about being out at night. I was out in Rapid. At midnight, we weren't supposed to be up. We were going to a gas station to get snacks. the cop pulled up to see if we were runaways because of rapid. I was the only one without an ID.
You're getting Cheetos. You must be running away from home.
The gas station was closed. We went and got pizza.
All right, that works. Yeah, that works. Like, just blah 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 things. How we doing with words? We practiced it in several sections. We spent the whole day on it in 6.4. Do you remember your 3 special forms? Standard is, what is standard in word problems? What does it look like? There it is. Rate for the first thing, rate for the second thing is total. All right, read the thing. Do they give me a total? They can spend 420 or less. That sounds like a total to me. So I know that we have $420. Oh, looks like a 6. That's bad. There we go. Looks like a really chunky 6. We'll take it. It says they can spend that or less. So what is that as an inequality? All my stuff's going to be over here. Less than, why'd you say or equal to? I can spend exactly $420. Anyone ever get the perfect pump? Like you just cha-chunk, 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 cha-chunk. You want to see if you can hit like exactly $35. And then it hits 35.01 and you just rage quit. Okay? So I can equal exactly $420. Cool. Maybe we should have actually done the variable thing first. What are 3 possible prices for wall, paper, and tiles? So right there, they told me the 2 things. Wallpaper and tiles. That's the very first thing I should have done instead of running over here for my total, is I should say, what the crap am I talking about? They're asking about wallpaper and tiles. So maybe I should say, this is wallpaper and tiles. I didn't think anyone used wallpaper anymore. Thought that died its horrible death in the 90s. Write a linear inequality for the thing. What are 3 possible combinations? Cool. But where's all my rates? There's no other word, or there's no other numbers up here. Look in the pictures, okay? Sometimes the pictures will have the information instead. They said they're going to remodel a kitchen. The wall above is blah, 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 blah. They can spend this much or less. And it tells me that I have 12 square feet of tile. Okay, so 12 is my rate for the tile. 24 square feet of wallpaper. Good thing I wrote down my X and Y, or I would have swapped those by accident because they were the other direction in my picture. Okay, so I'm going to make sure that I got that. And then, write a linear inequality, graph the solutions. To graph this, we did this last chapter too. I'm going to find my X and Y intercepts first. Plug in a 0 for Y. Divide by 24. What is 420 divided by 24? Even if it comes out nasty, that's okay. 17.5. The reason I need to know that is because I want to see my whole graph. And if I know that it's going to hit the x-axis at 17.5, I know that I need to go past just 10 boxes. Okay? What about my y-intercept? My yint. Plug in 0 for x. Divide. Okay? So that changes how I'm going to make the scale of my graph. I've got 10 boxes, and I need to go out to at least 17.5 for my x-axis. And since my x-axis is wallpaper, I'm over here like gonna oompa loompa my way through things. This is my wallpaper. I've got 10 boxes, and I got to get to 17.5. I'm going to go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 0. Now, I can't just say wallpaper and numbers. What is numbers wallpaper? Huh. Remember, these are rates. The rates told me what I'm doing. Square feet. The rates are going to determine my labels. My labels need to be on my graph. And then, crunch. I've got 10 boxes. I need to go to at least 35. Fives will fit. Okay. So we'll say 5, 10, 15, 20, 25, 30, 35 will be right on the nose. 40, 45, 50. What do I label that side? Square feet of tiles. There you go. And then, because I already found out my x and y intercepts so that I could find out how big my graph has to be, how about I just plot those 2 points and connect the dots? X-intercept 17.5. Y-intercept 35. Go get yourself a straight edge and connect the dots. Ooh, before I connect the dots, solid or dotted? More ink here, more ink there. Okay. So which way am I shading, though? Do I shade the triangle or the trapezoid off to the side? That's not a trapezoid. Okay. It says less than or equal. Put in 0, 0. 0 is, last time I checked, less than or equal to 420. So if this is a solution, everything on that side is a solution. Now, why were we given an L graph this time? Why can't I go down into quadrant 3? Can't have a negative square footage of something. Okay. And when you come back for Algebra 2 in a couple of years, that's actually something we talk about. It's called linear programming, where you set constraints like x has to be greater than 0, y has to be greater than 0. What if they say, well, we only have 12 square feet of this particular wallpaper that you want? Okay. Now it does ask, what are 3 possible prices for the wallpaper and tiles? And we just shaded that whole area. That just means pick 3 points in there. I could pick this number right here. That's in my shaded region. That's one of my possible answers. So I would say that 4 square feet of the wallpaper and 20 square feet of the tile. That's one possible combination that would keep me under 420 bucks. Just because you have 420 bucks doesn't mean you need to spend that much. Like, you ever done the, I don't think you all would do it here. You ever do like the mall trip? Here's $100, you have that for the rest of the day. Don't annoy me. Go. You ever do that with you in like middle school or something? No. When we were in probably 5th through 8th grade, that was always a thing. You know, those lame choir concerts when you're in elementary and middle school. Everyone has to do whether you want to or not. They'd make us go to the central court at the mall and sing for old people who wandered by. We got to do that in the morning, but then the whole afternoon you were free to just run around the friggin' mall like a bunch of animals. You, that day that you go in with maybe not $420, maybe it's more like $50. Don't you feel kind of good after the day if you still got that $20 that you can go do something else with? Or are you just going to blow it all? I mean, if you're that kind of kid, you're probably going to blow it all, but just pick anything in there. I can pick 10 and 5. I could pick 35 and 0. It's on the line. I could say, nah, I ain't going to do any wallpaper. Wallpaper's stupid. I'm just going to do tiles. Yeah, that works. So this is kind of a combination of everything we've done this semester. Can you label a graph? Can you make an equation from a word problem? Can you graph a line? Can you shade a line? Can you plug numbers into your own equation and tell me that they actually work? This is kind of the, like the boss level where you have to use all the different tools. Okay? You cannot defeat this boss unless you have the power bracelet and the hook shot. You got all the tools, let's see you go. Fork it over. Yeah. Yeah.
Would it be peanuts and cashews, or would it be just nuts and cost?
It would be the peanuts and cashews because those are the two things that they're asking you at the end. Those are your variables. Remember, what they're asking is your variable. In this case, they're asking two things, so those are your two variables. Your intercepts are good.
Okay.
Just make sure you call it 2x plus 4y.
Okay.
And then it says no more than. So what's your inequality?
So then it would be
Can you spend less than 12 or more than 12 if it's no more than?
less than.
Can I spend exactly 12?
Yeah.
So it's or equal to. There you go. I mean, it looks like most of us are getting this fine. We can take 3 or 4 of those for the weekend. Go to the cabin, sir. Just head out to the cabin. You're wasting your time and mine. Go. Pick up stuff. Bye. Go. Go. We'll see you next year. Well, I take that back. Greenwald will see you next year. Okay. What are the things we're asking? That's my variables. So label it as such. You got a total again. You got rates for each. And pay attention to the wording on it. No more than. Okay, less than or equal to. No more than means less. No more than means, well, I can have exactly that, and you're perfectly fine. Find your x and y intercepts again, tells you how big your graph needs to be. X-intercept 6, y-intercept 3, divide each. Okay, plug in 0, divide, plug in 0, divide. If I got x and y intercepts of 6 and 3 respectively, I got 10 boxes, am I good? Or do I need to change my scale? All right, we're good. Then write exactly what it says. Pounds of one, pounds of the other. Go make your x and y intercepts. 1, 2, 3, 4, 5, 6. 1, 2, 3. Connect dots. Solid line, more ink here, more ink there. If I were to put 0, 0 in there, 0 is less than or equal to 12, last I checked. Like we see on some people's grades. And everything in there. I asked for anything that is going to be a solution. If I have anything that's going to be a solution and it's in that little triangle, I can pick something right smack in the middle of it. I can pick something right on the edge. I can pick those intercepts. What if you're just sick of peanuts? What if cashews taste better? Could I do 3 pounds of just the cashews and no pounds of peanuts? Yeah, that's one of my solutions. Okay. I mean, I didn't put the numbers on there because if I'm going by ones, it's not a big deal. But I suppose I should put numbers. For those of you who are actually doing what you're supposed to be doing, are you good? Like, are the word problems clicking into place? Like, you see it's just that same pattern over and over and over? Okay, is it I can graph them, I just can't word? Or is it I can word, but the graph is weird? Okay, so from the handful who offer me any input, I would say, let's try that again. I don't worry about the graph this time. I think you got the graph. We need practice with the words. Don't bother graphing it. Can you just put this into Mathese? I want you to be very careful about what your total is. Not just total the number, but total the label. Aiden, why are you here? Just oh, okay. Okay, gotcha. Never did my attendance. See, the catch here is I have to change my rates because the total is in money. So that means my rates got to be in money. Don't want to spend more than 15 bucks. I know I got that much. That's my total. I should probably label my variables. The two things that they're talking about are small and large rides. Go find your rates that go with small and large rides, but got to put them in money. What do we think? Okay, so in our little graph here, dark blue will show up on there, right? It says small rides are 3 tickets. That ain't gonna show up. That's trash. Small rides are 3 tickets, but then over here, like that annoying little tidbit of missing information, they tell us that the tickets are 75 cents or 25 cents. So it's actually 75 cents to ride the small rides. It's 5 tickets at 25 cents each for the big rides. Okay. That's the catch. And we've saw this throughout our systems this chapter. If this is in money, then the rates also have to be about money. If they give me a total in number of yapping chihuahuas, then I have to have the rates for X and Y need to be the number of yapping chihuahuas. Maybe it's before or after curfew. How about that? Okay. You have to have the same label on your total and your rates. Otherwise, they're in the wrong equation, or in this case, the wrong inequality. Okay, and the very last thing about this is how do I go backwards? Well, we know how to make an equation for a line. Let's start there. Y is rise overrun x plus start. So I'm not going to put equals because now I know they're inequalities instead. So where did I start? Because start was my y-intercept. Start is when x is 0, y is thing. Maybe another way to write start instead, sometimes we've written that as 0, comma b, meaning my y-intercept at the point 0, comma, in this case, 2. So if I started at 2, I say plus 2. Yay. Can you find another nice point that that graph goes through? Nice integer intersection.
Isn't that just plus 1?
What? Oh, yeah. I'm distracted because I'm wondering how many phones I want to take down to the office. What do we think? Is there any other point? You can go find another nice point. Find a nice integer intersection. Any one of those. Between them, I go up to right 1. Up to right 1. That's why I put these over here. Because if I went up, I know it's positive. If I went right, well, I always go right, gets me my slope. Now the question is, what's my inequality?
It's gonna be equals 2 because it's all
Okay, chip away at it. Solid line, more ink here. Now, that's why I told you that shortcut. See, if I pick the point 0, 0, I can plug that in now and say 0 blank then 2 by 0 plus 1, 0 blank then 1. 0 less than 1 or greater than 1. Okay, but the other way to do it, if I'm going into slope-intercept form here, is just say, did they shade above or below the line? If they're shading below the line, then it's got to be less than, which is a lot faster. Okay, they gave it to you in words instead. You too. Stand up. Drop it all. Okay. Well, we didn't get the kathunk, so we got that going for us. Continue. I'll just hang out here. I'm telling you the pieces. Pretty quick. 15 days. 15 days. They told me slow. They told me a Y-intercept. Line above is shaded. Okay, it's bigger. They said it's dashed or dotted, whatever your jam is. So less ink here, less ink there. You're done. Okay, those should not be rocket surgery. And boy, is that taking us way too long. Your assignment's already online. And my patience has disappeared. Get work.